So far, you learned about converting between different quantities of elements. So for example, you learned how to convert between moles and particles, moles and liters, moles and grams, and then in the last chapter you learned about chemical reactions. So in this chapter we're going to incorporate both concepts and we're going to use chemical equations in order to be able to convert between moles or grams or particles of one entity, so for example a reactant, into moles, grams, particles of a product. And the purpose of this, the value of this, is that if we start with a certain amount of reactant, using our math skills and stoichiometry, we can determine how much of the product should be produced. But before we get into that, let's review some of the concepts that we've already talked about. Specifically, let's look at a chemical equation. So this is an everyday example. In order to make 5 pancakes, I need a cup of flour, 2 eggs, and half a teaspoon of baking powder. Remember that those 3 entities on the left-hand side, those are your reactants, while the one on the right is your product. So if I tell you I have 12 eggs and I ask how many pancakes can I make, if we do the proper setup, which I'm asking you to do even though it's an everyday example, I would start off with my given, which is 12 eggs, and then I'm going to convert into pancakes. So I'm going to put eggs on bottom, pancakes up top. Now here's the new concept. In order to relate pancakes and eggs, I'm going to use this chemical equation up above. I notice that there are 2 eggs required to make 5 pancakes. Okay? So 12 eggs will make 30 pancakes. So this is the concept that we're going to use. This is the only new idea in this section, specifically that we can convert from reactants to products by simply using the number of items. So for a chemical reaction, that will be the coefficient in front. So let's look at an example. If I give you this reaction and I ask you how many moles of ammonia are produced when 0.60 moles of nitrogen react, okay, the first thing that I have to do is I have to balance. Okay, so to balance, I'm going to put a 2 in front of ammonia and a 3 in front of hydrogen. Now I'm going to convert. So I start with my given, which is 0.60 moles of N2, and I'm going to convert into moles of ammonia, NH3. So I'm going to put moles of nitrogen on bottom, moles of NH3 up top. Now, here's where the recipe idea comes in. In order to make 2 moles of NH3, I need 1 mole of N2 and 3 moles of H2. So, if I want to convert from moles of N2 into moles of NH3, I'm going to put a 2 in front of NH3, and I'm going to put a 1 in front of moles of N2, because 1 mole of N2 is required to make 2 moles of NH3. And then all I have to do is multiply across, and I get 1.2 moles of N2. And that's it. This is the new concept. That's it. So we're going to add another step, and instead of just going from moles to moles, I'm going to go from, for example, grams of one thing into grams of another. All right, so for this conversion, it says calculate the number of grams of ammonia produced by the reaction of 5.4 grams of hydrogen with excess nitrogen. Okay, so I know how much hydrogen I start with, and it wants me to figure out the grams of ammonia, which tells me since I'm going from grams of one reactant into grams of a product, I'm going to need to use my stoichiometric conversion. So I'm going to start off in grams. I'm going to use this wheel. Remember, you're not going to have this wheel on your quiz or test, but this is just as a helpful guide in figuring out what steps you need to do. So I'm going to need to go from grams into moles of hydrogen, since that's what I'm in. Then I can go from moles of hydrogen into moles of ammonia. And so this is the new step, going from moles of one entity into moles of another. And all I need to do is use my mole to mole ratio in order to do that. Then I can go from moles of ammonia and get into grams of ammonia. Or if I wanted to for a problem, using the stoichiometry, you could go from particles of one entity into particles of another, or particles into grams. So you can use whatever you want. That's perfectly fine. The new
part of this is that I can go from moles of one entity into moles of another simply by using my mole-to-mole ratio. So let's actually do that. So I'm going to start off with my given. So my given in this problem is my 5.40 grams of hydrogen, so grams of H2. Now, before I go any further, I need to balance this reaction. So I've got 2 moles, I've got 2 atoms of nitrogen here, 1 atom of nitrogen here, so I'm going to put a 2 to balance that. Now I have 6 hydrogens, because 2 times 3 is 6, so I need to put a 3 in front of hydrogen there, and I'm actually balanced. So now that I'm balanced, what I can do is I can get into moles of ammonia. So the first thing I need to do, I'm in grams of hydrogen. I first got to get into moles of hydrogen. So I'm just going to show my setup. I'm not going to plug in any values yet. So I'm going to put moles of hydrogen on top. All right, now since I'm balanced, I can go from moles of hydrogen, which I don't want to be into moles of ammonia, because I want to get into grams of ammonia. Now that I'm in moles of ammonia, I'm going to have one more step, because I want to get into grams of ammonia. So grams of ammonia are going to go on top, and moles of ammonia are going to go on the bottom. So let's look at these units, make sure we agree that everything cancels out perfectly. So I have grams of hydrogen here. I'm going to cancel grams of hydrogen by putting them on bottom. I'm going to get into moles of hydrogen. So I am right here. Okay. Then I'm going to go into moles of NH3 by putting moles of hydrogen on bottom, moles of NH3 on top. Then I can get out of moles of NH3 and get into grams of NH3, which is my ultimate goal. Okay. So in order to do this, I need to plug in, since I have grams to moles, I need to put the molar mass of H2. Well, the molar mass of one hydrogen atom is 1.008. So since I have 2 hydrogen atoms, the molar mass is going to be approximately 2.02 grams for every 1 mole of hydrogen. Here, this is the new step, mole-to-mole ratio. For every 2 moles of NH3, since that's the coefficient for NH3, I have 3 moles of hydrogen. And in the last step, since it's grams to moles, right, grams per mole, I need to put the molar mass of ammonia. So the molar mass of ammonia, nitrogen is 14.01, hydrogen is 1.008, but I have 3 hydrogens, so the molar mass that I get is 17.04 grams for every 1 mole. So I'm going to take 5.40 grams, I'm going to divide it by 2.02, multiply by 2, divide by 3, and then multiply by 17.04. And so what I end up getting for that final answer, since I want 3 significant figures, is 30.5 grams of ammonia. And that is my final answer, and I'm done.